What's going on, guys? Welcome to another AI session. So today I will be talking about the hottest topic in AI research, and then later I'll demo some interesting results regarding this topic. One of the major limitations of large language models is compute, and by that I mean the tendency to run and train these models with the necessary hardware have become so expensive to the point that even large tech companies are researching better alternatives. GPUs, for example, which are the core hardware components for training large language models, are skyrocketing in cost. This has led to some innovative approaches in the open source community. And today we will be diving into one of them, and that is Llama.cpp or Llama.c++. So this is a very powerful open source code base by Ganavo and team. They are pushing the boundaries of this limitation that I've mentioned. So basically, they're using well-written C++ code to inference or run these models on CPUs, meaning anybody with a good enough laptop can run these models with just a few commands. Not only that, you can also build applications, say a chatbot like ChatGPT on top of it. So without much ado, let's dive right into the demo. So we will be doing two demos. One is a basic chat-based model. So we will download a quantized version of a chat-based model, this one right here. And then next, we will do a vision model. So you give it an image and then you query the model about contents of the image. So first thing we have to do is clone the repo, the Llama.cpp repo. I've already done that. And next, after that, you download the models. So I am using this one. You can download it from GPT4All. And for the Lava model, you can download them here. You need both the ggml and then the mmproj files. After you've downloaded them, then you place these models inside of Llama.cpp's models folder here. I created a 7B, which means 7 billion parameter models. And then inside of it, I have the Lava models, Lava files. And then outside of that, I have the the basic chat-based model that we're about to run. Then next, we just follow the instructions. So the first thing we have to do after you've cd into your Llama folder, you run make. So this will run, it's a very simple command, C++ or C command. So this will run the basic files needed to inference the model. And then next, what we have to do is run the server for the model. So you can find these in examples. Server. And then you look at the README, then you find how you can run the server for a particular model. So for example, here you use this command and then followed by your model path. So models / and then the path to your model and then the name of your model. Basic. So for that one, as you can see, this is the name of my model, the path actually. And then you just press enter and it will run the model, or the server actually, with the model. And then you can find the host here. So we have two versions. You have the web version for the chat-based model, and then you also have the terminal version. So first, let's try the terminal version. So for example, this one is in server, so you can just the Node.js chat-based app. So you just do node and then chat.mjs, press enter, and next it will prompt you to say something. Let me clear it up a little bit. So let's say hello. So this one crashed, but you can try it again. That happens sometimes. So let's say hello, how are you? So this model I'm using is actually well fine-tuned and it's given very interesting response. Like GPT 3.5 up to GPT 4 level kind of response. So it's really interesting. Okay, the server one is crashing a bit. The terminal one is crashing. So let's just use the web version of it. So here. So after you've run the server, you can access it here. And then here you can just prompt whatever you want to say. So let's say, hello, who are you? And then we press enter. Yeah, and then this one works perfectly. So you get, hi, I'm Llama. So you can actually change the name. You can edit, do some editing and change the name. So if we reset this is the Llama.cpp interface. So here you have the two options, chat or completion. So chat, you have a normal chat with the model, and then completion, you give it some content, and then you ask for it to complete the rest of it. And then here you have some parameters that you can adjust, basically. Yeah, so that's how you run the chat model. So next we will do for the vision model. So for the vision model, the instruction is very clear as well, very similar actually. So we just need to run this command. But first you need to do make lava. So the first one we did, we just did make. So for this one, we'll need to do make lava because it's actually the model we are trying to run. And then after you've done that, you will see make lava is up to date because I've already done that before. And then next, we just run the command for that. So this is a command in order to query the model. So I have my image here. You put your image. I created a folder inside of Llama.cpp. So call it images. So I placed two images here. This is one, which is also AI generated. And then this is actually a recent image. So we'll be using this one because it has interesting content. So we'll query the model about this one. Let's do that. So basically you run the command just like this. And then after that, so you have the model, it's two of them. Yeah, you specify the ggml and then the mmproj followed by the image path. So then next you have the prompt -p and then what you want to ask about this image. So what do you see? Let's see what it has to say. Okay, this can take some time. So I'll just skip to the completion. So yeah, finally we got the complete response. So as you can see here, this was my prompt, and then here is the response by the model. And as you can see, it actually got some of the details correct. So this is not a laptop actually. And yeah, futuristic and technological advanced background, as you can see here. And the chair. Yeah, so this is basically really good, as you can see. So we've been able to do this with just our small laptop, CPU, 8 gig of RAM, which before was thought impossible, in fact was impossible. And thanks to some of the amazing work by some of the brilliant minds out there. Yeah, so stop here for today and then see you in the next one.